This is a second video on section 2.5, the cross product. And so here we're going to look at example 60. Example 60 is going to show us that the cross product is not associative. In the last video we saw that the cross product was not commutative. When you take a lot of math classes, you're going to see that there are a lot of operations that aren't commutative. But many of those operations, let's use composition of functions for example, that aren't commutative are associative. So it's a little bit more surprising that the cross product's not associative than it is that it's not commutative. But it's not. And so for an example, we have our three vectors, u, v, and w. Now in the notes, it's just simply asked as a question, can you find three vectors that have this property? So here, this one solution I'm giving you is, let's take these three vectors. So let's take u cross v, and I'm not going to work through the details, but u cross v is the vector 1, negative 2, 1. U cross v is the vector 1, 0, negative 1. And then we take u cross v, which is 1, 0, negative 1, and we cross that with w. So here we have u cross v cross w. That is the vector 1, negative 2, 1. So here we take the cross product of u and v first. We take that vector and we take the cross product with w. For the second calculation, we're going to we'll take the cross product of v with w first, and then we'll take the cross product of u on the left. We have to be conscious as to whether we're doing this on the left or the right, because we already know the cross product is not commutative. So we start with v cross w, that's the vector negative 1, 1. And then we take u, this is the vector u, cross v cross w, and we get the vector 0, negative 2, 2. This is u cross v cross w. So we take the cross product of v with w first and then with u on the left. So we have u cross this vector. Okay, so cross product is not associative. Then we have Theorem 61. Theorem 61 has a lot of properties of the cross product. And so this would be a good time probably to pause the video and look at all of those properties from Theorem 61. So we know that there are some things, well, as I've said before, there are things in math that work the way you want them to, and there are things that don't work the way you want them to. So if you look at Theorem 61, you're going to find some of those things are things that you would expect, and some of them are perhaps things that you would not expect. So I'm not going to spend recording time going down through all 10 of those properties, but now would be a good time to pause and study that list. Theorem 62 has a formula for the sine of theta, where theta is the angle between two vectors. So we know the cosine formula. Now we have something for the sine that involves the cross product. Remember, dot product is a number, cross product is a vector. So when we take the cross product of v with w, that's a vector, so we take its magnitude, and that's a number. So the sine of theta is the magnitude of the cross product divided by magnitude of v times magnitude of w. That is the sine of theta. A fairly immediate corollary is that two vectors are parallel if and only if their cross product is the zero vector. Note 64, and I'll mention this in the next video because we're actually going to use this, is if you want to take the dot product of the cross product of two vectors. Remember, dot product's a number. So when we take the cross product of v with w, that's a vector, but then when we take the dot product of u with this vector, that's a number. that number is actually the determinant of the matrix that we get when we put the components of U in the first row, the components of V in the second row, the components of W in the third row. The determinant of a matrix is a number. It can be positive, negative, or zero, but it's just a number. Dot product of two vectors is a number. How do you calculate that number? It's similar to the technique that I told you to help you remember the cross product in the first place. So you look at U1, you ignore the row, you ignore the column, and then you perform this operation here. V2 times W3 minus W2 times V3. You take that and you multiply that with U1. Then for U2, ignore the row, ignore the column. You have V1 times W3 minus W1 times V3. That's what we have here. We multiply by U2 because we're at the U2 place, and we subtract because it's in the second position. You will learn this in more detail when you get to linear algebra. For the U3, ignore the row, ignore the column. We have V1 times W2 minus W1 times V2, and we multiply that by U sub 3. And then we add these three numbers together. Remember, dot product is a number, and in the end we have a dot product of two vectors here. V cross W is a vector, U dot another vector is a number. And I will refer back to this in the next video because we're actually going to calculate, we're going to do an example with this, and I'm also going to show you an application of this.